Hello, Summit Climbers. Mr. McKee here with you. And I want to go over this skate park PhET that you did recently in class. And I'm not going to go over all the questions with you, but I want to walk you through the animation, the virtual lab. And that should give you enough information to be able to figure those questions out on your own. I also want to remind you that I'll post the key on the calendar as always. So we're going to start here with the intro. That's the skate park system without friction. And we're going to get our skater going here. And I'm going to pause this skater at the top of the ramp. And I want to draw your attention over here to our bar graph. And at this point, you'll notice that the potential energy and the total energy are basically the exact same. And that's because the skater's at the top of the ramp. So all the energy is stored. It is gravitational potential energy, if you want to be more specific about it. But the skater is motionless at this point, okay? So there's no kinetic energy associated with the skater. But let's hit the play button now and watch all this potential energy is going to start to convert to kinetic energy, and it's going to max out at the bottom because that is where the skater is moving the fastest. Let's see if we can pause at the bottom. Not quite at the exact bottom there, but you can see, again, at our graph, you can see that at this point, almost all of the energy is kinetic energy. And if the skater was at the very bottom of the ramp, then indeed we would have 100% kinetic energy at that point. So moving up and down the ramp, the energy is converting from kinetic and potential energy. But if you add the two of those together, it's always going to add up to this total energy amount, because this is a system without friction. So that's the only two places that the energy can go in this system. As we're going to discuss here in a minute, this system is not realistic because in an actual environment, you are always going to have friction. You're going to have friction between the wheels of the skateboard and the ramp, and you're also going to have friction between the air and the skater, okay? So this system is kind of simplified and not very realistic, but it illustrates how energy shifts from kinetic to potential energy here. And you'll also notice that we don't have any thermal energy because we don't have any friction. But when we go to the friction system, we're going to see the thermal energy come into the equation. So let's do that. Let's click on the friction button down here and move into a system that is more like how things actually operate on Earth. And I'm going to move the skater all the way up to the top, and we're going to get the skater going, and watch the bar graph as we do this. Notice we still have this shifting from potential to kinetic energy, but also notice that we have this growing amount of thermal energy. And the other difference that we have here is that the skater is slowly coming to a stop, because all that initial energy that the skater had eventually gets converted into thermal energy. So where did the thermal energy go? Well, because of friction, that's the rubbing between the wheels and the ramp, a lot of that energy went from the skateboard into the ramp and actually heated the ramp up a little bit, kind of imperceptible. Although if you felt the ramp, you might feel just a slight elevated temperature there. And some of the energy was lost as friction in the air as the skater moved through the air. And that's not really something that you're going to be able to measure unless you could somehow close off this system completely, put the skate ramp inside of a bubble and monitor the air temperature very precisely. Then you could measure those changes, but they're very subtle. But all that energy eventually gets converted to thermal energy related to friction. So friction and heat kind of go together. Okay, and that is the basics of this system. The important thing to remember is that no energy was actually lost. And that is the first law of thermodynamics. So we started with this amount right here, and we ended with this amount right here. And the energy changed forms. It went from kinetic and potential energy into thermal energy, but the overall amounts are exactly the same. If they weren't, then we'd be violating the first law of thermodynamics, and we can't do that, okay? As always, reach out to me if you have more questions. Thank you for checking in, and have a fantastic day.